In this video, we will learn about PCA algorithm, how PCA algorithm is performed in Python and data science and machine learning. Actually, it's a dimensional reduction technique which is used to reducing the number of inputs variables from a data set. First, we need to understand what is PCA, statistical procedure that allows you to summarize the information contained in large data tables where we are having data from one dimension to another dimension. So if you will feel, if you can check, the data set is always more than one dimension, right? If this data set is plot against x and y column, so this what is the dimension of this data set? Of course, it's two dimension. It's a 2D scatter plot. And suppose I am having only single axis and my data set is just plotted on this, the same line. So what is the dimension of data set? This is called one dimensional data set and it is 1D diagram. Alright, so if coming back to two-dimensional data set, if I am having scatter plot in this way, my data set is plot on the x and y axis in this way, where I can create a line or a single straight line to predict a new test values, then I can say that this line is my regression line or the classification line. But anyhow, if I can convert this data set into one-dimensional data, this two-dimensional data set can be converted into one-dimensional data set, then I can do using rotating my axis. So these are new axes for my, according to my data set, accommodated with the data points. So ensuring you have been adjusted all the data sets and you have equipped with all these data set along the same rows and column. So anyhow, most of the data points have come across one dimensional data set. So this is the beauty of PCA, where we can convert two-dimensional data set or higher dimensional data set into lower dimensional. Either way, in a simpler way, I can say I can convert two-dimensional data set into one-dimensional data set. Here you can see that PC1, principal axis 1 and principal axis 2, that is perpendicular to the principal axis 1, is scattered from all the random data set. So it's using eigenvalue, is using eigenvector to assign the different values. Right? So now I am going to convert the mathematical part, how we are going to convert the data set into a different values. So suppose I'm having a vector which is having equation t of v is equal to t of v, which is multiplied by single value. Why am I obtaining this value? Because this can have this vector originated from origin and then coming across x and y axis. So this vector is having certain value. This might have, like, this one is x axis and this one is perpendicular to y axis. Now across the v value I am having the value of v vector. So this v vector is going to integrate with any certain value. Now I can have the different components of my vector, which is having maximum argument or the another argument. I can take the transpose of the vector, or can have the matrix value. Okay, how we can obtain the matrix value? Suppose my data set is scattered all over the x-axis and y-axis. So this data point will have contain x1, y1. This will have x2, y2. This will have x3, y3, and all data set can be drawn in a single or two-dimensional, like x and y matrix. So this matrix is going to calculate along the x-axis and y-axis. So anyhow we can say that we can convert this data set into matrix format. So this matrix format will go with the mathematical calculation, and this mathematical calculation will have eigenvalue and eigenvalue and Rayleigh quotient also we will see in later upcoming lesson. So next we will calculate covariance vector will calculate the value of this. Then we will be no information loss, but correlation between features will be lost by using the covariance matrix. Dimensionality reduction, which is the ultimate goal, of our PCA technique. So data are centered on the origin. We can try to fit a limit to it. To overcome from overfitting model, we can say that it is going to predict from one dimension to another dimension. Similarly, single value decomposition can have the first value and the transpose value. Now you can say these are the properties of PCA. Those are involving with single dimension and two dimension and more than one dimension data. So like in PCA we always do standard scaling, so we are having certain coefficients also. So this is done for vertical part. Coming to the coding section, I have opened my Jupyter file. So first and foremost we will import all the necessary files, like import matplotlib.pyplot as plt. Next library I am going to import numpy as np. Thirdly, I am going to import pandas as pd, and then I am going to import matplotlib in line. So matplotlib inline is an example of predefined function in IPython. It is going to use to set up the matplotlib to work interactively anywhere in my session, in my entire session. Then I just hit run. Then you can say it is going to enable the inline plotting and remove inconsistencies, remove data and all these data set. So next I am going to import my dataset from sklearn library, sklearn dot datasets. I'm going to import load underscore breast cancer dataset. Just hit run, and then try to import this dataset to one another variable. Let's say cancer only, but b, then parenthesis. Then suppose I want to check how many key values are there, how many columns are there in my data set. So I am having data, target value, frames, target names, ESCR, feature name and file name. Suppose I want to see the details of my particular file. Let's say TESR. What are the content of this DESCR, this keyword DESCR table column. So I'll write my function name cancer and then obtain the respective value. So breast cancer dataset consisting breast cancer with point dataset, it's having characteristics 5, 6, 9 instances are there, 30 numerical predicting values, and all these theory is there, and how many minimum max value are there, other parameters are there, right? So this is how we can obtain the entire description of a single column. Likewise, you can check the other columns also, what are the ingredients and what are the content of this function. Then the main part we are going to cover, that is pdf dot frame with a file name, and then let's say we have to explore that data, then column, how many columns are there, and then insert, and then another feature name, feature underscore name. So this df a new variable, and this ed dot data frame, maybe I have written a wrong name, so it's names, not name. Okay, so COLUMNS. Then I have imported this data frame from my pandas using my pandas library. This is the two-dimensional data. Using the dataset and columns features name, I have imported this dataset into df variable, and then try to find what are the first values of this dataset. Okay, so this is having mean radius, mean parameters, compact, mean value, and means 30 columns are there. It's a huge dataset, so I can say lots of prediction is going to perform here. Again, I am going to import my sklearn library, sklearn dot pre-processing import min max scalar. I am going to scale my dataset using minimax scalar, right? So I can also use standard scalar for my standard scalar for my set, because standard dataset is using for my for the normal distribution, and where we can perform the other dataset also, how it is going to differentiate from standard deviation and all. So then again I can inherit this value, this function into my dataset, this another value that is called standard scalar. So I am going to copy this code here and copy followed by parenthesis. Then again I can say how to fit that code, scalar dot fit, and then this entire data set. I have used this standard scalar normalization technique, then going to import this scalar function into scalar variable, then scalar variable is going to fit my entire data set. This df is consisting all my data set. Now I can check what is the scaled data. Alright, So before that we can say means scale data is equal to scalar dot transform standard scalar, then we can say scalar dot transform, and that this is going to transform my entire data set. So I can see what is the scale data is there. So scale data is already converted into normal distribution. So you can see no columns are there, only values are there, because I have means I have reduced the values into scalar definition. Now again I am going to import my sklearn dot decomposition. This time I am going to import my actual file, that is PCA with PCA, and then hit run. Meanwhile, till now it is going to import the actual file, actual library. Till now I can create a new variable consisting my PCA with how many components I need. Components. So components I need 2 only, means I want to convert this data set into 2 component. So then means I want to reduce the data set into 2 components. So I'll give it n components is equal to 2. Then next I am going to fit this code, this entire data set into with my scaled data, which I have just scaled in a data set. Then again it's showing it has converted the entire data set with 2 components only. So now you can see how XPCA is going to transform my entire transform with scaled underscore data. Alright, then scaled underscore data. I want to check the shape of this variable. It's having 569 rows and 30 columns. Okay, and also I want to check the XPCA dot shape. Again it is having 2, because earlier it was 30, now it has changed into 2 variables. So 30 columns has converted into 2 columns. 30 columns are not that much effect to predict any value, are not having that much role. Some of columns are having least role while predicting my target value. So this has converted into 2 most significant values. Now I can check how my scale data is looking like. So it's having the certain value and it's having certain excess value also. You can check what is the PCA value here. It's having only 2 columns because 2 columns are required only. Now I want to create the graph for the same. So this is I am using plt.figure. Then what's the figure size? Figure size is equal to 8,6. Then I can see plt dot scatter, and then what is the XPCA? I am going to plot XPCA with 0, means I want to create all these rows, but 0 means first column only. Then what is the y-axis? For y-axis I will create like all the rows column, second column, all the rows with second column. Then what is the target variable, that is the x answer with target variable. So that is going to define here. Then what should be the x label in my case? So x label, plt dot x label should be different, like FIST, first principal component, principal component. Similarly, I can have the label for y axis also. So for that I am having y label, plt dot y label. So this is using second principal component. Okay, I'm going to run this code. Okay, let's see. Plate has no x label, so it's label. Also, it's label. So this is how my data is looking on the screen. This is first principal component along the x-axis. This is the second component, and we can have the entire value on the different data set, and which is also linearly separable. You can see that the data set can be divided into two separate lines using a single okay, if I use a single line, of course I just draw it one more time. So if I'm using a straight line in between these two classes, so they are linearly separable, right? Thank you.